So this video is going to be about using SOHCAHTOA to help us write the actual trigonometry ratios for different reference angles. So what I want to start by doing is I want to, for angle X, identify where the opposite, adjacent, and hypotenuse sides are. Now, the hypotenuse is the easiest one because the hypotenuse is always across from the 90-degree angle. The reference angles don't actually play a part in that. So for this example, and all examples going forward, the hypotenuse is always opposite the 90-degree angle. So the hypotenuse in every single ratio that we write will always be 17. Now, the side that's opposite angle X means that it's on the opposite side of the triangle. Okay, so if this is angle X, for this example, 8 would be my opposite side. The adjacent side is always right next to the angle they're asking me about. So in this example, 15 is the adjacent side. It's right next to angle X. Now, let's go ahead and write these ratios. The sine ratio, S for sine, is always the opposite side over the hypotenuse side. Well, for angle X, my opposite side is 8, and my hypotenuse is 17, so the ratio for sine of X is 8 over 17. Simple as that. Let's write the same ratio, but now for cosine. The cosine ratio, C for cosine, is the adjacent side over the hypotenuse. For angle X, the adjacent side is 15, the hypotenuse is 17, so cosine of X is 15 over 17. We're just writing fractions here, and SOHCAHTOA tells us the order the sides should be in. We have one more to write for angle X. Okay, the tan ratio, T for tan, is the opposite side over the adjacent side. Well, for angle X, the opposite side is 8, and the adjacent side is 15, so my ratio is 8 over 15. Pause the video and see if you can write the ratios for angle Z. Hopefully you were able to work some of them out. Sine of Z. Well, before we can write any of these ratios, we need to identify how these sides relate to the reference angle. Okay, the side opposite angle Z is 15. So now for angle Z, our opposite side will be 15. Notice that wasn't the case when we had reference angle X. Okay, so when we change the reference angle, we change the opposite and the adjacent sides. So now everything in blue is what we're going to use for angle Z. Sine of Z would be 15 over 17, opposite over hypotenuse. Cosine of Z would be 8 over 17. Tan of Z would be 15 over 8. Now, the other part of IXL is evaluating trig functions on a calculator. I know some of you did not bring your calculators home, so I was able to find a free Desmos scientific calculator online. If you have your own calculator, just make sure that it is in degree mode, DEG, because if you notice on IXL, the trig functions we're evaluating are not a ratio. This time there's angle measures inside. So when we type this into the calculator, it's about as straightforward as you'd think. Our trig functions are on the lower left. I want the tangent of 26. I don't even have to hit enter or equal. I don't have to close the parentheses if I don't want to. I just like to get into a good habit of doing that for some later problems that we do, but your answers will show up on the right-hand side. Now, it asks for rounded to 2 decimal places, the hundredths place, which in this case, since our decimal is 0.487, we'd have to round it up to 0.49. And it's as simple as that. Some will ask for tan, some will ask for cosine, some will ask for sine. Just make sure that you pay close attention to the trig function that they want you to use and that you type in the correct angle measure as well.